So before we get started, I'll ask one or two questions that sort of helps me calibrate the interview a little bit better. Is that okay?
Sure.
One thing, is there anything specific that you're looking for? Is there anything specific like that? Any specific topic or anything like that?
Not really. So I'm about to start the process of hunting for jobs. So what I wanted to do was have this session, just as a sort of like reality check in terms of where I'm at now, so that I can understand how I'm doing now, then go away for like a month and do some like leak code and practice and other things, and come back after a month and do another one. So just sort of to get me warmed up to this whole sort of engineering process.
Okay, cool. Yeah, that's was gonna be my second question. Do you have any specific interviews lined up, like at Amazon, Google, or something like that? But
No. So most of the companies I'm applying to are finance. So think of like banks and hedge funds, that sort of thing. So that's what I'm targeting.
okay, yeah. So like in the spirit of full disclosure, I worked at Amazon, so I can only advise about that process, maybe a little bit about Google, but nothing else.
That's fine.
So okay, we'll get started. First of all, like any specific language you have a preference for? Because I don't particularly mind any. You can select whatever you.
So I'll do this in Python.
Okay. Python. Python 3. I selected Python for you.
Okay.
Yeah. So what we'll do is, I'll provide a question. Go through it. Ask me any questions you want. Anything you're not clear about, any clarification you need, anything where you have a doubt. Ask me anything. Then you sort of come up with an algorithm. We'll go through it. If you both agree on it, you code it out. Make sense?
Okay, sure.
We'll do this till around 55 minutes. The last
Okay.
5 minutes I like to reserve to sort of highlight some of the salient points I saw throughout the process. Like obviously, I'll be providing a detailed written feedback post the interview, but like generally, I like to sort of point out that this is an important point that you should look at. This is an important point you should have for posterity and stuff like that. Okay,
Okay, sure.
cool. So let's yeah. Oh, one final thing, and this is something you should expect. Like, doesn't matter if it's a finance company, it's a tech company, anything like that. Expect, especially given that this is not a video interview, but even in video interviews where you see the interviewer, you see them looking down, you see them looking on a different screen, you hear the sound of their keyboard. Don't get distracted. Most of the times, and most decent interviews will inform you directly, but even if they don't, they are listening to you. They're just typing it out. Taking notes is a part of most interview processes at most companies. Okay?
Okay.
Yeah. So basically the question, please take a look.
Okay, so I guess my first question is, in this context, what is defined as a shape?
That's a stand first question. Good. So what we are defining as a shape is a collection of ones joined together. So that the joining is an important part. Otherwise, each one could be its own independent shape. That's not what we are going with.
Mm-hmm. Mm-hmm. Okay. I guess I need to understand the question a bit further, because how I'm looking at this, I'm seeing three, but this should provide us with two. Um,
Okay.
so like,
So
which sets of
yeah.
ones are the straight?
Okay. So these two are definitely a shape. You see line 15 and 16 last column.
Yes.
Same with line 12 and 13 last
Yes.
column.
Mm-hmm.
So these are two shapes, and they're the same. They're congruent. That's how we're defining the uniqueness aspect here.
Oh, I see. I see. Okay.
And then obviously we can come to the the first column and the second column shapes, but okay, we'll come to that. But first,
Mm-hmm.
if you have any other questions on that.
Mm-hmm. Okay, and so this matrix, in terms of the algorithm, what's the input that we're checking for the unit shape? Like how would it be inputted to us?
Okay, let's not worry about the input a little. Let's park that question for a minute.
Okay.
And you see what the third shape is? This whole first column,
Mm-hmm.
it's connected to the second column, uh, row 14, which is
Mm-hmm.
connected to row 13, second column, which is connected
Mm-hmm.
to this one. So this entire thing is one shape.
Mm-hmm.
That's how
Okay.
we have three shapes, right? And because these two are same, two ones pointed downwards, that's why we have only two unique shapes. Now, as to the question of what form the input will be provided, generally speaking, and in most questions, that is not a big thing. Like, assume the input is generally provided as whatever you want it to be, because your task is not to receive the input from the user. Your task is merely to give out the solution. So in this case, assume you have to write a function where the input is coming as a method parameter in form of
Yeah.
a 2D array.
Okay. Hmm. Um,
So what are you thinking about? Like, it's generally a good idea to sort of talk out loud, to think out loud. So basically, like if you're thinking about something, if you have something coming up in your mind, even if you think it's a long shot or something like that, even if you
okay.
haven't fleshed out your theory, it's okay to do your spitballing out loud.
Okay. Okay. So I guess. Hmm. Okay. So I guess just on a high level, how I'm thinking of this in my head
Sure.
would be to go through this 2D array, sort of row by row, and
Okay.
then. Okay. So for example, let's look at the first row. We've got 0001.
Yeah.
So what I'd be doing is I check the given row that we're at the moment, and if I find a one in that row, so how we've got like this um, one here,
Yeah.
then okay, we keep that index, and then we check the row beneath it to see if there's a one in that same index,
Okay.
and then if we find another one here, then we'll check the next row to see if there's another one there, but we know there's no one there, so we know that okay, these two make a shape. But then I guess the tricky part that I need to figure out how to do is these two ones have a shape, and then these two ones have the same shape as these two ones, so that they'd be the same thing effectively. So how to, I guess, sort of track the uniqueness of them is the next bit that I need to figure out.
Right. Right.
Okay, I guess maybe I can just get started with the initial one.
Okay. So, uh, okay, coding, I don't think it would be the most productive thing right now because we haven't sort of the main thing that you did, you broke down the problem into two separate parts, which was nice. Getting a shape and then sort of deduplicating the shape. But
Mhm.
getting the shape, I feel we are not in a very strong position to do that yet. For example, I mean, these two are simple shapes, so it's fine. What about
Mhm.
this? How would we capture this entire shape?
Ah, yeah. Yeah. Okay. Okay, I see your point. So I guess,
Uh, Let me ask this because I feel like if you're not making too much headway, this question is not one of those where you can. There are some fundamental aspects that you need to know, given that this entire session is more of a mentorship thing. There are
hmm
fundamental aspects algorithms that you need to know before you tackle this kind of question. It's a
hmm
build up on something that exists. Are you familiar with DFS or DFO?
yeah, I've come across that before. But okay, I take your point. So
Yeah.
yeah, that's
So these are two things, and I'll provide a list of things that topics that you should take a deeper look at. But
yeah.
so this is something that's required because that's how you capture a shape. Both
Okay.
will work, but I mean, if you, but like they're tied to their deduplication as well. So yeah, point being, these are required.
Okay.
Without this question becomes uh, quite difficult. Okay,
Yeah.
let's progress to a different question. Okay, hang on. Take a look at this one.
Okay. Give me a minute to. Um, huh. Okay. It's given. Okay. Um,
You understand the question?
yeah. Just a question. So, in terms, I guess, for the context of this question, will the array always be sorted? Um,
Excellent question. No, I've
okay.
sorted the array just as an example, but no, there
Yeah.
is no guarantee that it will be sorted.
Okay. So I guess. Okay. I think I have some ideas in my head
Sure.
for this.
Good.
So, okay, I think the first thing I would do, the approach I want to take, we need to sort the array. So the first thing I would do would be to one, sort the array first.
Okay.
Sorry, I'll just put
Oh, that's fine. We are not running anything, so don't worry too much about that.
okay. Then the second step that I would want to do is I would want to iterate through the array, right? So for each, so let's say we look at the first number, whatever the first number is, we'd want to check if the next element in the array is equal to that number plus one,
Okay.
and then keep doing that. And then the first time where we see where current element plus one does not equal the next element, then current element plus one is the answer.
Right. That makes sense.
So I guess
Okay. So
what I would want
you start with sorting,
to.
then you start at the first number. I'm
Hmm.
recapitulating what you just said just to confirm that like my understanding is right or did I miss something?
Yeah, sure. So I would want to iterate through each element in the array, and then for each element in the array, I'll check if the next element is equal to the current element plus one.
That's fine. Right. Okay. Why don't we write the code for this one? Doesn't sound overly difficult. Assume you have most libraries have a sorting function, so you don't really need to implement any of that.
Hmm.
Uh, like full confession, I'm not an expert in Python, so I'm not sure what library Python uses for this, but Java has a simple function. I'm assuming Python would also have it, so
Hmm.
we can just use that.
Sure. It's usually something like list dot. sort. So let's say we have an insert list. I'll just put some.
This is another thing I want to point out. In
Okay.
general, it is expected that you always write a method. So it's never, the ask is never to sort of start writing code directly. It's always to write a method that takes most of the input as the function, as function parameters.
Okay.
That's the general standard.
Mm-hmm. Mm-hmm. And then okay. Okay. So um, okay. So first step would be to sort the list, and then next step would be to iterate through the list. Um, so let me think. So I'll do something like current. Let me make it the index.
Okay.
So I'm just trying to think
Okay.
of the cleanest way to do this. Okay, we can do something like for, um, okay. Anyway, I'll come back to that. So, okay, so let's go back to using this example. So I would want to look at index. So this would be indexes 0, 1, 2, 3.
Right.
So for index, okay, so I'll do something like current element equals our input list at
Right.
index. Right.
Makes
Um,
sense.
then I was gonna do
Don't
something
worry
like
too much about the edge cases. First, let's write the meat of the logic. We can worry about edge cases, overflow later.
okay. Sorry, say that again, please.
Oh, I was just saying, like, if you're worried about maybe over index overflow or something like that, or edge cases, I was saying let's not worry about those right now. Let's first write the basic conditions that we need to fulfill. We can worry about those later.
Okay, sure, sure. So okay, so the current element we're checking is um, So what I'm doing is I'm going through each element and then basically seeing if the next element is equal to the current element plus one. And if that's not the case, then we're returning next element, which is basically just the current element plus one. So in this example here, we're checking, so 2 plus 1 equals 3, so we're checking the next element, but the next element isn't 4, so then we return 2 plus 1 effectively, which is 3.
Okay, makes sense. Works for the base case. Now let's talk a little bit about the edge cases.
Mm-hmm. Okay, so I guess one of the edge cases could be um, the list is empty.
Okay, I mean those are sure, those are base edge cases, like those are input related. Input list is null or empty. Assume those
Mm-hmm.
are sorted, like sorted in the sense those are taken care of. What
Mm-hmm.
other edge cases you feel your solution would fail in?
So I guess another case is, okay, so we've already determined that they're always going
Fail
to be non-negative, so we don't have to worry about negative numbers.
What do you think the answer should be in this case?
In that case, 4.
Right. And what do you think?
Oh, okay, okay. Okay, I see your point. So if all the numbers in the array, okay. So the smallest element would be at the end of the array. Oh, okay. I just need to think of how we can do that. So I think we can do that in the check here. So if, okay, I need to change this check bit. So if,
We just need to place some conditions, right? We don't need
yeah.
to check completely. We
So I
just
guess
need to make. Sorry, go ahead.
I was going to say something along the lines of checking if the index is the last um, available index of the element, of the array, sorry.
Yeah, that's a reasonable check.
Mm, It'd be something like if index equals um, length of insert list minus 1,
Okay.
return. Since we've already defined next element here as the current element plus 1, so then in this
Yeah.
case, we'd already have that value, so we can just return that next element value.
Right. Okay. This takes care of these two. Now let's talk about another case. What do you think the answer should be in this? You see the input?
Mm, I would say either 0 or 4. But in terms of, okay, so when we're finding the smallest non-negative integer in the array, I was kind of basing it, I was kind of using the baseline as being the first element in the given array. But then I guess for something like this, 2, 3, it would
Okay,
be 0.
so yeah, it's 0. Let's assume there's no baseline, there's nothing like that. So the
Mm-hmm.
answer should be 0. So can we accommodate that?
Mm-hmm. Okay, so it'd be something like, um, if the current, okay, but we don't know. Okay, so we've gotten the current element. So if current element is not equal to 0, then we return 0.
Okay. Uh, do you see a problem with this?
Oh yeah, this we'll keep hitting this outside.
Yeah.
We'll, we're
So this
gonna keep
will,
it.
like, the first element is 0, but this will run when second, third, fourth element also runs. So
Yeah.
at least one of them will be non-zero, which
Yeah.
will automatically make it return 0. Yeah.
Mhm. Mhm.
So how about we put it outside? Or maybe just add another check here. We only need a certain element to be 0, right? Which element should be 0?
The first one.
Yeah, so why can't we put a check for that as well?
Yeah. Um, something like uh, equals input. Actually, no, I'll just clean up that. If input list first element at 0 is not equal to 0, then we return 0. So then that way we're only ever hitting response. So if this passes, then we know that the first element is 0, then we can do the rest of it in here.
Absolutely. That makes sense. Okay.
Mm-hmm.
So I think now this is a working code. This will cover edge cases, this covers everything.
Mm-hmm.
Okay. Now let's before we proceed, what's the space and time complexity of the solution? Are you familiar with the concepts?
Yes, I'm just a bit rusty. So I think in terms of the time complexity, so the worst case scenario is that we have to loop through every element in the list, but it's
Right.
linear because we'll only, if we do get to the end of the list, that'll only happen once. So it's directly proportional to the number of elements in the list. So I would say that the time complexity is O of n.
Okay.
Um, oh, actually, but that I guess that doesn't factor in the time for the sorting algorithm.
Exactly.
Oh God. Okay. So if I would need, okay, so I guess that's a point for me if I'm going to use built-in libraries like this to understand um,
Okay.
like the time
This
complexity because if it's,
this part I'll just point out. In most cases, generally speaking, most library functions also sorted this way. The general expected time complexity is this n log n.
okay.
Java has it this way. I'm reasonably certain Python would also have it this way
Mhm.
because you use reliable algorithms and they all sort it n log n.
Yeah. Yeah.
So what would be the total complexity of the entire solution?
Um, so I guess we could say it would be O n log n plus O of n, but I believe O n log n is the worst one between the
Right,
two. So we would say then this is O n log n.
right. That makes sense. What about space?
Oh, okay, that's something I need to look at. So, I mean, I guess the benefit of this is that we're doing this check in place. So we're not like copying it into like a second data structure. Um,
Right.
so I would say something. I can't. I'm not sure of the syntax of it, but I think it would be something like n.
Okay. Why? Assume that input is generally not included in your space complexity issue. Input
Uh,
resides outside. So are you using any extra space? And is that proportional to the length of the input that you've received?
not really. It's just we've got a couple of variables. Um,
Right.
so since we have a couple of variables, but we don't have like another full-on structure where we're copying um,
Okay.
the input, so I guess it would be relatively low.
Yeah. Okay. So that's generally called sort of constant. You just generally put O of 1.
Okay, got it. Thank you.
That's constant. Yeah.
Yeah. Okay.
Okay. So, feel yeah, we've done well here. Let's move on to a bit of a change. So we got time as n log n. We got space as O of 1 in this
Hmm.
particular solution. Let's say the ask has changed a little. My ask here is, can we do something about the time? We can take more space if required, but I need the time to go down a little. Would it be possible?
Um, so in
As in the
order
ask,
to,
think of a solution, think of a different solution, or think of a different approach where we could reduce the time even if it takes more space for us.
okay, so I guess the first thing that comes to the top of my mind is when we were initially looking at the time complexity, I had
Yeah.
identified two elements. So the n log n was for the sorting, and then the O of n was for the iteration. And we had identified that n log n is worse, therefore we call the time complexity of that n log n. So I
Right,
guess if we wanted to improve upon the n log n, we would have to explore whether it's possible to do this without sorting.
right, correct. So far, so good.
Uh, how can how do you do this without sorting?
Okay, so think of it in this way. You're almost on track here. Think of
Mm-hmm.
it this way. What is sorting helping you do? When you're checking whether next element is this or that, what is it helping you accomplish? It's helping you accomplish a check that ascertains whether this particular element is present or not, more
Mm-hmm.
or less.
Mm-hmm.
And that's why you're doing sorting. Is there
Mm-hmm.
something else that can tell you in a much quicker format whether a certain element is present or not?
Um, okay, so I'm thinking along the lines of using a dictionary or a map.
Yeah, yeah.
Um,
How do we use it?
so I guess the first thing I would do is I'd create a map and
Okay,
then populate that map with all of the elements in the array. So it would be a set of key value pairs. So the key would be each number in the array. Then the value could just be, I don't know, true or something.
yeah, that's fine. It could be a random thing. Yeah,
And then once we have that map, we can then sort of rapidly check for the existence of certain numbers. So for example, I could create a loop that runs from zero. So, and then at each iteration of the loop increases the number by one. So we'd have checked for zero. Does the key zero exist in the map? Does the key one exist in the map? Does the key two exist in the map? Until we find the first number that is not existing as a key in the map, then we return that number.
Excellent. Yeah, that's it. That's exactly it. We could just use. Are you familiar with sets? Like we have maps, we also have sets, we also have arrays, linked lists. But yeah, so set you don't even need to set the value. It's like a map, only
Mm,
just the keys,
okay.
values. So in this case, as you said, we only need the keys.
Yeah.
Obviously, in any actual sense, it makes no difference. And point of fact, in Java, set actually uses a map, so it's a bit of a funny thing there. But yeah,
Okay. Got
okay.
it. Thank
So
you.
I think you'll be able to code it out because you sort of told the right solution. Okay, let's change the question a little bit more this time.
Mhm. Okay, I guess if the array is already sorted,
Right.
then I think we can just stick to the original approach, but then we'd ignore the sorting and then just start checking from 0, 1. So I think I'd do something similar to what I was saying before, where we have wait, no, sorry, let me think about this again.
It's not a trick question. So, I mean, you were more or less on track in the beginning.
hmm Yeah, I think it would be similar to this. So we just sort of do like an iteration, like a loop, starting at 0. Um, hello?
Yeah, yeah, yeah. I mean, yeah, makes sense.
Oh, sorry, something happened to my screen.
Oh,
Um,
sorry. Did it toggle the whiteboard? Or do you see a white screen or something?
yeah.
Uh, Go to the bottom left. There should be a
hmm
toggle whiteboard option. Click on that, please.
Okay, got
Yeah.
it.
It
um,
happens sometimes. Yeah.
okay, so what I was thinking was just if we can assume that the array is already sorted, then we just do like a standard iteration. So we start at 0. Um, so we just check does element at index 0 equal 0? Then does element at index 1 equal 1? Then the first index where we find that it's not matching, we just return that index.
Makes sense. Okay. Now, what's the time complexity of such a solution?
So that the worst okay, so the worst case scenario of that sort of solution is that we loop through the entire array once, so it will be directly proportional to the size of the array, so it will be linear, so O of n.
Okay, good. Now, let's type that out for a second. So we have an OFN solution. Now, my ask is there any way we can improve on that? Reduce it, basically.
As in reduce the solution that was already O of n.
Yeah, obviously. I mean, OFN, because we have taken out the sorting. So as you said, it's linear, it's OFN. Now, the ask is to reduce it from OFN.
Huh. Okay. Hmm.
Okay, I'll ask something here. Uh, are you familiar with binary search?
Um, is that the one where we sort of like half the array each time?
Yeah, that's the one.
Okay. Oh, okay, that's interesting.
Okay, so if you're not well acquainted with that, this would be much more difficult.
Yeah. Okay, binary
Yeah.
search.
Okay, so binary search should help you accomplish that. Uh,
Mhm.
the main question is what is the main thing that you check to compare. Uh, but yeah, so if you're not familiar with that, this would not be a big thing. Okay, so that takes.
Okay.
Hello, can you hear me? Sorry, I
Yeah,
disconnected for
yeah,
a bit.
sorry. I'm here, sorry. Yeah, I was just thinking about it. Yeah, that makes sense.
Okay, give me a second. Let me pull up another problem then.
Okay.
Okay, I don't have a visual for this, so let me just type out the question. This is a pretty standard kind of question, but
Mm.
I feel this is not a bad question to discuss in 10 minutes
Mhm.
because there are some key points in it I find interesting. Are you
Mhm.
familiar with trees at all? I'll paste a sort of create a quick node class for you as well. So
Mhm.
what you should expect in each of your nodes is. So it's still giving an error, but yeah, as I said, Python is not really language, but yeah. So basically, you have a tree node, val, left, right. The ask
Mhm.
is given a root. You are given a root tree node. So method looks like something like this. Def, you don't provide.
Okay. Um, if I remember correctly, with a binary search tree for any given node, or the
Yeah,
value in any given node, the
right,
node dot left should be less than, and the node dot right should be greater than.
right,
So if we're looking at a particular node, let's say that node has a value of 10, the
right.
left node should be something less than 10, and the right node should be something more than 10, and that should exist throughout the entire tree. And if that exists throughout the entire tree, then we have a binary search tree.
True.
Okay.
There is one more issue, and this is
Okay.
something messed a little. It means that, let's say the current node is 10, anything to the left. It's not just that the immediate child to the left should be less than 10.
Hmm.
The entirety of the subtree that will spawn on the left side should be less
Hmm.
than 10.
Aha. Okay.
Okay? Same with the
Yeah.
right. So obviously analogously, but same with the right.
Hmm. Okay. I think for this, I imagine we'd be using DFS for this, depth first.
Mm, okay, sure. Uh, yeah, pre-order, in-order, post-order, they're all more or less the same. So
Oh
in this
yeah.
particular
Okay.
case, that particular order of traversal is it's not the main thing that's going to impact our solution.
Okay. Hmm. Sorry, my memory is foggy on BSTs because I remember it has a bit of a recursive element to it, doesn't it?
Yeah, so that's with most trees. So okay, let me paint
Mhm.
out a tree here.
Mhm.
This should be, yeah, something like this.
Mhm.
You start at 5, you have 3, 7, 6, and 8, and you are given 5.
Mhm.
So obviously, in most cases, in most tree questions, you have to use recursion because recursion is the easiest way to process all of the data.
Mhm. Mhm.
So we could try writing something recursive that calls the same method again and again.
Yeah.
Let's create our own method. So this is the input method that only has root. We may need more things
Mhm.
rather than just root, right? In our
Mhm.
recursive method.
Mhm.
And we can always call our method from the initial method. So let's create another method where we can vary the number of parameters and stuff.
Okay.
Okay, for val, so what are we checking? Val is, I'm assuming, the value. So value has to be compared against stuff, right?
Yeah.
Yeah, node. Node is fine.
Mhm. Um, um,
We'd also need something else, right? We can come back to obviously and change the method method signature, but I'm just
mm,
asking. We'd need like the entirety of 314 tree left subtree has to be less
mhm.
than 5.
Mhm.
And when you actually go right from 3, so it has to be less than 5 but greater than 3. So assume instead of 4 we had another subtree here, an entire subtree here around 4. 4 would have been a big subtree. Now in this entire 4 subtree, every element has to be greater than 3 but less than 5,
Mhm.
right? Because at 5 you come down, so it has to be less than 5. 3 you go right, so it has to be greater than 3. And this process will keep continuing every time we go down. So we know the constraints. At
Mhm.
every element, the route that we take to come down, that defines some constraints for us, doesn't it?
Yeah.
And we would need that for every node.
Mhm.
So we can add that to the message signature as well, right?
Mhm.
The minimum and the maximum that between which a particular node should lie.
Yeah. Um,
Yeah, that was right. Min val was right. So what was the issue there? Let's check for current node if it lies between these two.
Hmm.
Right.
Then, oh, okay, we'd want to call this function again, but with,
Now we need to check the others, the entirety of the subtree beneath the current node. Those need to
yeah.
be checked as well. So at this point, we can call using recursion, right?
Hmm.
Are you, yeah. Um, are you familiar with the syntax of recursion? Basically, you call the same function.
Yeah.
Would be simply check, kind of like, so you call check again.
Hmm.
With what values would you call check? How do you check the subtree? You go left and you go right,
Okay. So we'd pass in the node dot left.
right? Now, is it the same min value and max value, or is there one value that will change?
No, we've got to change it because now, if we're looking at the left always has to be less than its current parent. So the parent of node dot left is node.
Right? So no dot val, we wanna pass the
Yeah, yeah.
value. What about max? It's okay if we can't make any reductions about it.
Um, hmm.
We can't
Sorry,
make
it's
any.
escaping me right now.
We can just put it max val because you can't really make any reductions about max.
Hmm.
We also need to run this for right.
Yeah.
Now it's gonna be exactly the same or same as left, or should we change something?
Oh no. There needs to be one of them is supposed to be men. One's um.
Uh, so everything to the right has to be greater than the current value. So that supplies us the minimum value, right?
Oh yeah, yeah, yeah.
Yeah, close enough. We yeah.
Mhm.
Give me a sec. Manual max also be less than this. We reversed the values, but other than that, yeah.
Oh yeah. Okay. Right.
Yeah, the node dot val should be on the other side. In left, you
Mhm.
define the maximum value that can be
Mhm.
attained now.
Yeah.
On the other hand, in you define the minimum value. Okay. So I would ask the space and time complexities, but especially for trees, they go even more. So can you tell me what the space and time complexity of this would be?
So the time. Hmm. But I feel like it would be something worse than O of n because for every node in the tree, we then have to check its left and right nodes. Um, I was going to say something like log n or n log n.
Hmm. So n log n will be greater than n anyways. And
Mm.
so, okay, take a look at the map. So are you checking the entirety of the map? Let's say, uh, sorry, map, tree. So in
Mhm.
the sense that, so if this proves false, you don't check the entirety of the subtree at all. You check nothing. You
Yeah.
return immediately.
Mhm.
But say if it's a perfectly valid binary search tree,
Mhm.
there is no issue. Then how
Mhm.
many nodes do you end up checking?
Um, every node in the tree. In the tree.
And how many times do you check every node?
Only once.
Right. We only check each node once,
Mm.
and in the worst case, we have to check all the nodes. So if there are n nodes, what would be the time complexity?
O of n.
Right. Okay.
Oh. Okay.
Yeah. So space is also there. I mean, you'll say that space is constant because we are not using any variables,
Mhm.
and you're right so far. So the heap space used would be O of 1, but the trouble is, recursion is built on stacks, basically method stacks. So anytime you call something, so
Mhm.
that method 1 calls something which is in method 2. Method 2 calls method 3 calls method 4, and no, method 1 has not been terminated. They're
Mhm.
still ongoing. This builds up a recursion stack.
Mhm.
So every language deals with that in a different way, but overall, this stack space is the general term that's used. The
Mhm.
stack space is used. So in
Mhm.
that, it comes out to, if it's a balanced tree, it would be log n, because the depth that you'd go at any one point is not more than log n for a balanced tree. Generally, BSTs, even BSTs, there is no guarantee that they will be balanced or not. So there
Mhm.
is a possibility where your binary search tree is nothing more than just a single chain. 5, 4, 3.
Mhm.
So it's because you keep going down left, 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 and that's it.
Yeah.
5, 3, 1. It's just left, 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 left. Nothing else. Rights are always now. So that's just a single chain. So in that those cases, it's O of n. Okay, I think, oh, we are over time. So I'd like to take a few more minutes to discuss a few things if that's okay with you. If you're busy, I'll understand.
No, it's fine. It's fine.
Okay. Uh, so let me go over my notes here a little. Okay. So overall, I feel you did reasonably well. You were able to come up with things when I pointed them out. You were able to think about things, but I feel there is a fundamental lack of knowledge here. There is a gap in the things that you don't know about, which which is relevant because no matter how good of a thinker you are, interviews have a time limit. You
Mhm.
can't come up with an original solution, like you can't come up with binary search in 1 hour. Even if you
Mhm.
do, you wouldn't have time to implement it properly.
Mhm.
So knowing things matters here. So if you're just starting out, I'll let me now go above. I'm on line 7 or something. Come to that. I will write down a few topics that I. How do you do that? Yeah, few topics that I feel you should cover in depth.
Mhm.
Binary search being one of them.
Mhm.
Linked lists, arrays, you're already done. Let's go with the what's the queues slash stacks. But yeah, these are basic data structures.
Mhm.
Uh, let me those two pointers. These are handy things.
Mhm.
Graph, VFS, basically DFS. This you can leave for a bit later. Okay,
Okay.
I'll put this for a later tag. The above one is what you should get cracking on immediately. If you are only vying for quant positions or something like that, I'd suggest dynamic programming should also get upgraded to first to
Okay.
grow. Yeah,
Mhm.
binary search is quite important. Like I have
Mhm.
interviewed for Goldman Sachs, I
Mhm.
cleared it. I know they ask binary search quite a bit, and
Yeah.
it's just a standard binary search. They even use it for numerical approximation.
Okay.
So like there are mm, questions where you use it to approximate a few things or figure out based on trial and error rather than actually figuring out from a point of view what value would fit best. You put in a value and see if it would work or not. That's it.
Mhm.
So what else? Okay, I'll also give you a link. Link code line 75. I would start with neat code 150, not the blind 75. Blind 75 is for people who already have a solid grasp on the fundamentals
Mhm.
and who are just looking to refresh.
Okay.
Refresh, as in they want to get back, they want to practice so they have a feel for coding in real time again. I feel here we could work a little bit more on building up our foundation as well. That's just my opinion.
Okay.
Yeah. So this is once you have it, go through neat code 150
Mhm.
code. This should only be done like after you've studied these topics.
Okay.
How to study? I think you can find geeks for geeks problems, problems on lead code. Uh, there are books, topic, courses, whatever. There are tons of free resources, so I wouldn't advise paying for anything.
Okay.
Yeah. What else? There are books I can recommend where you can read up these topics on. Also, Neat Code also has a list of topics.
Mhm.
So practice has a bunch of topics. It's a topic by topic practice.
Mhm.
So you get to learn that okay, this is a topic I need to read up on. These are some of the practice questions. Yeah, something like that.
Mhm. Okay. Got it.
Q stacks. Give me one sec. Let me just quickly see if there is any specific thing that I wanna call out. Tree, backtrack, greedy. Yeah, trees is also one thing I highly recommend.
Mm.
Yeah,
Okay.
because the reason I'm recommending trees is because in compositions etc. You don't have to code a lot. So what the expectation is that solution might be a little difficult, but it doesn't involve a lot of coding. And binary search, two pointer and trees, these kind of things, they don't really involve a lot of coding. The number of lines that you'll spend in code will be very less,
Okay. Got it.
but the solution could be a little convoluted.
Yeah.
Once you figure it out, it will be 5 lines of code overall.
Mhm.
That's it. So something
Mhm.
like that. Like this BST solution, there is one check, null check, then there is a check if the current node satisfies the thing. If it doesn't, you just return false. So these are two lines. Then the next three or four lines are just left and right, and you do a simple ampersand and bitwise and that's it.
Mhm.
So these things actually come in handy quite a bit. So these in particular, let me put it in ordered way as well. This is the order that you should go in. These are like not the order you should go in, but this is the importance order.
Okay.
Separation. Like binary search is very important, so it's two pointers and trees. These are like highly important.
Yeah.
Linked list queues obviously you should know as well as dynamic programming. But yeah, GFS comes later.
Okay. Got it.
Okay, I think that's more or less all I have for you. Anything else I can do for you?
No, that's all right. Like I found the session super useful, so thank you.
Okay, sure. Well, uh, good luck.
Thank you.
Okay, cool.
Bye.
I'll provide the detailed feedback after this, and yeah, you will both get the opportunity. So anything you feel I could do better, please don't hesitate. Always happy to learn. Okay.
Okay, sure. Thank you.
Well, thank you.
Bye.
Bye.